Alright, IM2 student, welcome back to another day of absolute value equation. We are doing chapter 2.2, day 1. Content standard. Solve each variable equations and inequalities involving absolute value, graphing the absolute values, and interpreting them in context. Language objective. Describe to a partner why solutions to a variety of absolute value equations makes sense and contain more than one solution or no solutions. Solving absolute value equation graphically. Absolute value equations differ from linear equations in that they may have two solutions. This is indicated with a disjunction, a mathematical statement created by connecting two other statements with the word or to see why there can be two solutions. You can solve an absolute value equality using the graph. Right. So this is referred. Okay, so then we said 2 absolute value of x minus 5 minus 4 equal to 2. So first, I'm going to change it to red. Right. So we're going to add 4 to both sides. So then we have 2 times absolute value of x minus 5 equal to 6 divided by 2 on both sides, right? Okay, so then this gives us an absolute value of x minus 5 equal to 3. So remember that absolute value can be positive or negative. So we say that x minus 5 equal to 3 or x minus 5 equal to negative 3. So solve for so x equal to 8 or x equal to 2, right? So then we can see that on the graph. Okay, so then we can break it into two graphs. So then let's say that your y1 equal to 2 absolute value of x minus 5 minus 4, and the other graph y2 equal to 2. So let's graph the x of y2 first. So 2, we have this graph here. Okay, so then I'm going to switch color. I'm going to graph this in blue. Right, so from our 2.1, we know that the vertex for this one is 5, negative 4. Right, so the vertex is 5, negative 4 is here. Okay, and then you see that our A is 2, B is 1, H is 5, and K is negative 4. So then the point we say that it's going to be 1. Let me erase that. So it's going to be 1, 1. It's going to go over XB plus H and YA plus K. Right? So it's going to be 1 times 1 plus 5. And the other one is 1 times 2 minus 4, so it's going to be 6, comma, negative 2. So 6, negative 2 is here. Right, so that's our vertex, and the other point is going to be, we're going to go negative 1, 1 is going to go to XB plus H and YA plus K. So it's going to be negative 1 times 1 plus 5, so it's going to be 4. And it's going to be negative 2 as well. So it's going to be here. So when you graph, our graph going to do this. Okay. So where they cross is this point and this point. So this point is that 2, 2, and this one is going to be at A2. So this is matches with these 2 points. So A and 2. Okay. So example 1, solving absolute value equation algebraically. So then here we need to solve for x, right? Remember that we will always, an absolute value will always get you two answers, either a positive A or a negative A. Okay. So say so start from this paragraph here. Notice the use of a disjunction here in the rule for value of x. You cannot know from the original equation whether the expression inside the absolute value bar is positive or negative. So you must work through both possibilities to finish isolating x. Right, so let's look at this equation here. So then we said that absolute value of 3x plus 2 equal to 8. So we need to isolate x, so we're going to minus 2 from both sides. Okay, so then this gives an absolute value of 3x equal to 6. So once we have the absolute value by itself, then we can say either 3x equal to 6 or 3x equal to negative 6. And then solve for x, so x equal to 6 divided by 3 is 2, or x equal to negative 6 divided by 3 is negative 2. So we have these two answers here, 2 or negative 2. Right, let's move on to our next one. So we need to solve this equation. So first we need to isolate the absolute value equation by itself. Right, so then we said we have 3 times the absolute value of 4x minus 5, close to absolute value, minus 2 equal to 19. So we're going to plus 2 from both sides. So 3 absolute value of 4x minus 5 equal to 21. And then divide by 3. So absolute value of 4x minus 5 equal to 7. So once we have the absolute value by itself, then we can say 4x minus 5 equal to a 7, or 4x minus 5 equal to a negative 7. And then we can solve for x, so then 4x equal to 12, so x equal to 3, or 4x equal to negative 2, so x equal to negative 1/2. Right? So then if you look at our dot, it will be x equal to 3 or negative 1/2. Okay, slide number 5. So solve each absolute value equation algebraically, then graph the solution on a number line. Right, so as before, we need to get the absolute value by itself. Right, so here we have a 1/2, so do the reciprocal, so times by 2 over 1, times by 2 over 1, so we get an absolute value of x plus 2 equal to 20. So once we have the absolute value by itself, then we can say x plus 2 equal to 20, or x plus 2 equal to negative 20. And then from there, we can solve for x. So x equal to 18, or x equal to negative 22. And then we can see that on our number line, right? Okay, so let's go on to number 4. So now here we have a negative 2 times 3x minus 6 plus 5 equal to 1. So first step is to minus 5 from both sides. So we have a negative 2, absolute value of 3x minus 6 equal to negative 4. Divide both sides again by negative 2. So we have absolute value of 3x minus 6 equal to negative 4 divided by negative 2, give us positive 2. So now we have the absolute value by itself, so we can say 3x minus 6 equal to 2, or 3x minus 6 equal to negative 2. So solve for x, so 3x equal to 8, so x equal to 8 over 3, or 3x equal to positive 4, so then x equal to 4 over 3. Okay, so that we can graph those on our number line. Right, so let's move on to number 6. So here we want you to try this out. Okay, so here, how many solutions does the equation have? So then you have to work this out. So then set its absolute value, we can say x plus 7 equal to 1, or x plus 7 equal to -1. So then x equal to -6 or x equal to -8. Right, so we have two solutions. Okay, and then for number 2, how many solutions does the equation have? So we said x plus 7 equal to 0 or x plus 7 equal to -0. Well, -0 is the same as a 0. So when we solve x equal to -7, so we only have one solution. Right? And here we have an absolute value plus 7 equal to a -1. Well, remember that we said that for an absolute value, the answer will always be a positive, right? But here we say that it's equal to a -1, so this one we have no solution. Okay? Let's go on to number 7. So can you guys try to solve this one out? Right, so I'll give you guys a minute to work this out. Okay, it's important that you write the word or. Okay, the same thing, so I'll give you guys a minute to work this out. Okay. All right, so that's the end of our Module 2.2 Day 1 notes. So that's your assignment from number 1 through 8. And you also have your new HRW. Right, instead of 1 through 10, if you know it, you can do more than 10. Right, and we need you to copy down 2.2 Day 2 notes. Right, everyone, be safe and be happy.